So let us start that we design the raft for the bottom reinforcement. You can also increase the number of the layers, but for the simplicity and for the make it easy for the construction, I will recommend you go for the as much as lower number of the layers. So we will be giving you two layers in reinforcement, in which the first layer is the number 8 at the rate 6 inches center to center, right? And we are providing 1.6 inch square per foot to the raft. And in the second layer, again, we are providing number 8 bars at the head, 6 inches center to center. And again, we are providing 1.6 inch square per foot. The total is 3.2 inch square per foot we are providing in our bottom reinforcement, right? So if you want to check it in here, so you have to divide this by the area of the bar, right? So this is the area of the bar. 0.8 is the area bar of the number 8 bar, and then divide the total area of reinforcement you have provided, and multiply by 12, you will get the 3 inches center. So you have to insert these 3 inches in here, and you can check it, right? So there is no issue for the total reinforcement.
Sir, assalamu alaikum, sir.
वालेकुम अस्सलाम.
सर अगर इसमें हम सर दो मुख्तलिफ बार यूज़ करें तो फिर ये दूसरा जो स्पेसिंग है 3 इंच जो हमने अभी फाइंड किया, इसको फिर हम किस तरह कौन से नंबर वाले बार से फिर फाइंड करेंगे, लोअर वाले से या जो हायर है? मतलब अगर हम नंबर 4
काइंडली ये चीजें आप नोट कर ले, इसको आप हम लास्ट में डिस्कस करेंगे. क्वेश्चंस काइंडली लास्ट में पूछा करें.
ओके सर,
ठीक है जी. I will answer all of your questions. ठीक है, जो भी क्वेश्चन आपका होगा मैं आंसर दूंगा. So this was the whole story for the bottom reinforcement. Let us check the top reinforcement. First of all, let us check the pattern. If you can see that there is a less demand at the mid, but there is a huge demand at the corners because we have the retaining walls. Retaining walls and shear walls will also try to pick more negative bending moments and more shear. That's why it's giving you more reinforcement at the edges, right? So again, we will use this command, and we will check it for the number 6 bar, and we'll click on apply. I'm at the rate 12 inches, but still you can see there is no significant changes in the reinforcement. So we'll make it as 6 inches center to center. So now you can see again the pattern has been changed, but not significantly, because if you do not change the bar dia, it will give you 3 layers, 4 layers, and which we do not want, because the construction for 3, 4, 5 layers is very difficult, right? So we'll go for the higher bar, that is number 8 bar, and we'll click on number 6 inches. So you can see that the top bars at the mid has been become 0, but it's still asking about the negative reinforcement at the edges. This is the direction 2, and the direction is the X direction. X direction, it is still asking you for the second layer, right? So again, for the top reinforcement, we have provided number 8 bar. It is the area of number 8 bar, and we have provided it with number 6 inch center, and we have to multiply with 12 to get in inches. So again, you are getting providing 1.6 inch square per foot in the top. So again, if you provide it in at number 8 at 6 inches center to center, so again you are providing 1.6 inch square per foot, and the total again will become 3.2. So now you want to check, if I provide 3.2 inch square per foot in the raft, will it work or not? So for this, you have to find out the bar size and the spacing, which will be checking in safe. If you are using number 8 bar and divide it with the total reinforcement and multiply with the bar, so you are getting, if you check it with the number 8 bar, you have to provide the spacing at 3 inches center to center. Click on the apply. So now you can see that the negative reinforcement for the direction 1 has been become 0 in all of the cases, but still at this corner it's asking you for some reinforcement. So let us check in the direction 2. So now you can see that there is significant reinforcement again at the top for the lift, that I have explained earlier, that we do not have the capability to design our actual lift pit because this is the case for the lift pit, it's asking you the more reinforcement. But if you want to provide another layer, 3 layer only in these regions, you have to give it again number 8 at the 6 inches center, so the spacing will become 1.5. So now the reinforcement has been reduced very significantly, and now you can ignore these reinforcements as well. If I go to this, so there is no demand. Now you can see you will have, if you provide number 8 bars at 1 inch center, still it will give you some reinforcement. You cannot make it 0, right? This is because we do not have the capability to model this lift pit accurately. So this is how you done this design. So for the design of raft in bottom layer 1, we are using number 8 bar at there 6 inch in center to center. And for the second layer, we are again using this number 8 bar at the 6 inches center to center. And there is no need for the bottom layer in the third layer for the bottom. What if there is demand, for example, if you are designing your structure for the 16 story or the grid size is increased, it also depends upon the number of the story, number of the layers. Number of the layers depends upon the number of the story and the grid size, right? So we have do not that much longer grid size, so we will work with the 2 layers, right? The top one we got again, this is the number 8 at the rate 6 inches center to center, right? And for the second layer, again we have this, and we have this top layer 3 as well at the corners of the left. So this is the overall design of the raft in different layers, and the length for the bars in layer 2 was 8 feet, 8 feet in X and 8 feet in Y direction, right? And for the top, let us go again to the save. So this is the second layer. It is asking about the second layer in this region. So you have to calculate this region by the same procedure like the coordinates. So you can check on here the maximum, that is the in X. Like on the X, we have 98, and in here we have this 113. So if you subtract this, you will get the length for this second layer, and same for the other direction, right? And you will do this when you sit with the draftman, that you have to provide this much reinforcement in this region, this will be the length of the bars, and this much will be the layers, right? So this is how the procedure we do in our daily design practices, right? So the next is the some limitation on the reinforcement, that the maximum spacing reinforcement is CA 31814 limits for the maximum spacing reinforcement, that is same for the 2 slab and ramps. Say that it says that the maximum spacing should be the 2H in 18 inches. So 2H, we have this H is our H is 39 inches. So if you multiply it with the 2, so you will get 78 inches center to center. And the next one is the 18 inch center to center. But we have provided all of the layers at 6 inch center to center. So we are on the safe side. So this is how you do the design of raft in different layers. So if you have any question in the design of the raft, you can ask, so we will go forward. I have prepared some of the plans for the reference, that how you will present your drawings, right? So if you have any questions, you can ask.
ओके सर, आपने बताया कि ग्रेड्स जो है वो छोटे होने चाहिए. ग्रेड्स मतलब छोटे, 2 ग्रेड्स के बीच में फासला कम होने चाहिए, एक तो ये बात है. और सर 2 कॉलमों के बीच में ये डिस्टेंस ये आर्किटेक्ट तय करेगा, वैसे कोड इस बारे में कुछ कहता है?
देखिए जी, आर्किटेक्ट्स कोड मोड को नहीं जानता. देखिए ये आपके पास, मैं बात कर रहा हूँ कि ग्रेड साइज मीन्स ये आपके पास ग्रेड साइज है 15, 12, और दूसरी साइड पे आपके पास 1912 है। ये साइज अगर आपके पास 25 से ज्यादा हो जाए, 30 यहाँ ये साइड पे 30 है, इस साइड पे 30 क्रॉस 30 ग्रेड है, तो आपके पास जो राफ्ट की थिकनेस है वो बहुत ज्यादा आ जाएगी। आपके पास रेनफोर्समेंट भी 3 4 5 लेयर्स तक आप जा सकते हैं। तो आप आर्किटेक्ट ये तय करता है कि ग्रिड साइज क्या होनी चाहिए। ये क्योंकि आर्किटेक्ट सारे प्लानिंग करता है कि यहाँ पे मेरी जो कॉलम है वो शॉप में ना आ जाए या मेरे कमरे में ना आ जाए, इस वजह से वो इसको बचाते बचाते ग्रिड साइज काफी बड़ा हो जाता है।
ठीक है
तो
सर।
सर
इसका पंचिंग जो है सर, इसकी पंचिंग किस तरह होती है कि मतलब जिधर कॉलम और राफ्ट का जंक्शन होता है वहां पर ये फट जाता है, इस तरह कुछ फिनोमेना है?
जी जी बिल्कुल, ये आपके पास जो राफ्ट है ये इसी तरह जिस तरह हम स्लेब में होता है, लेट मी शो इट इन हियर फॉर एग्जांपल, ये आपके पास राफ्ट है, ठीक है जी, ये आपके पास राफ्ट है, उसके साथ ये कॉलम कनेक्टेड है, ठीक है जी। तो आपके पास जो
जी
इसकी जो पैटर्न होगी क्रैक्स होने की, वो आपके पास इस डायरेक्शन इसकी पैटर्न होगी, सो इट विल ट्राई टू पंच, तो ये आपके पास इससे निकल जाएगा, तो आपके पास ये इस शेप में नजर आएगा। इफ आई एम नॉट दैट गुड इन प्रिपेयरिंग दीज ड्राइंग्स, तो आपके पास ये जो कॉलम है वो डायरेक्टली इससे इस शेप में निकल जाएगा, पंच हो जाएगा, राइट।
ठीक है
ये आपके पास इस तरह पंच हो जाएगा, तो आपके पास सेटलमेंट हो जाती है, पंच हो जाता है कॉलम, आपके पास कॉलम फेल हो गया तो आपके पास सारी बिल्डिंग फेल हो गई।
ठीक है।
yes, sir, how we prevent that punching in Raft? How we prevent?
Were you not in this session?
Yes, I come this part in the session, but I understand that punching that it may be happening punching in a Raft, but how we prevent that punching? By
So I have already explained it in this session, but let me explain you quickly that if the demand to capacity ratio is greater than 1, then we have two options to overcome this ratio or to prevent this punching. The first option is to increase the depth of the raft, right? So when you increase the depth of the raft, the punching issue will be solved. If you do not, if you cannot increase the depth of the raft because you have restrictions from the architect that you cannot give raft thickness greater than 36 inches. The second solution is the integral beam, that you have to design the integral beam, and we have designed integral beam in our safe, and I have explained it. If you came later, you can check it out later in the recordings.
Okay, sir, I understand. Can I ask you, sir, another question?
Right, please.
Sir, yes, we use Raft. Why we don't use our pile? Because our store is 14 stories, so we need to use pile. Does we need to use pile foundation?
You can use pile foundation if you have lean soft clay and you have water tables above the, for example, if this is the level, let me show it in section. For example, this is the level of your raft, and your technical report says that the the water table is located below 20 feet or 15 feet below the road level. So in that case, you will have to go for the pile raft design. And if you have very soft clay soil, that is called as lean clay, and it is classified as SE or SF by the Building Code of Pakistan or UBC, then you have to go for the pile design.
So now we assume our soil is hard soil, so we don't need any pile.
Yeah, this is the designing training course, because we are assuming we assume the allowable bearing capacity is a 2 TSF.
Okay, sir. Another question. We use two bottom layers and we use 3 top layers. Sir, we say we don't need 3 bottom layers because the bottom layers depends on the number of story. But how we take 3 top layers? If you go back the slides.
This actually you have seen that normally the negative bending moment is more in beams and slabs. That's why we are using more reinforcement. But there was no need to give 3 layers at the top. But for the demonstration purposes, I've already explained that due to the lift pit, we are incapable to design the actual lift pit design in Raft. So that's why it's giving me more reinforcement at the lift location. You have seen that the third layer was not on the other locations. It was with the near lift locations, right? So you can give top 2 layers, you can increase the dia of the bar, right? And you can increase the number of the layers by decreasing dia of the bar.
Okay, sir. Sir,
Right.
can you little bit understand me that that layers, how the layers will be? How that layers will be?
Outer layer will be what?
In the layers between the two bars, they cross or they will put parallel. They will be in parallel or they will cross the layer. How layer will happen? That layers will happen. I cannot imagine that layers.
Let me show it in here. This is the case, right? I have drawn this. This is the bottom layer 1. This is the bottom layer 2. And if you have any bottom layer 3, you can give this third layer as well, because now we do not have any third layer at the bottom. So you will delete this layer. So this is how you will give the detailing. You will take a section on the raft and you will tell the engineers that I have this layer 1 and it is at the rate this inch center, and this is the bar diagram, and this is the column. And same for the top, you have to provide this layers. For example, let me show it here because you have asked this question before. I was going to show these reinforcements to you. This is how you will represent the number of the layers at the top and the bottom.
Okay. I understand, sir, now.
Right?
Now it's clear. Yes,
now it is
clear now. Yes.
Right?
Thank you, sir.
And you have to write the length of that bar. We have calculated it was 8 feet, and you have to write the length of that bar as well as the second layer. Because the first layer is continuous, the second layer is 8 feet. Same for the top. If it is 8 feet or 13 feet, you have to write the dimension for it.
Okay.
Right. So this is the
Right.
section for the raft in different layers. If you have 2 layers, 3 layers, 4 layers, you can show this, and you have to write the thickness. For example, in our case, it is 39 inches, right? And 3 inches is the lean for the cover, and you have to write the reinforcement. For example, in our case, we have number 8 at the rate 6 inches center to center, right?
Right.
Right, and delete this, and you will have to copy it here, and you have to provide the arrow, make a copy of this arrow and show it in here. This is how you will represent your drawings, final drawings, right?
Right.
So this is the top, in which we have 2 layers under the columns, but we have 3 layers under the near the lift. You can show all this detailing as well as a separate for the lift. I have prepared this for the column. At the column we have 2 layers, and at the bottom we have 3. Sorry, at the top we have 2 layers at the column, and again we have 2 layers at the bottom under the column. Right, so this is the section I have taken from the raft. So if you have any questions, you can ask. Otherwise, I will go towards the general detailing of the reinforcement, how we represent your drawings.
सर बॉटम में सर हम अगर 2 मुख्तलिफ बार यूज करते हैं तो ये स्पेसिंग फिर हम किस तरह फाइंड करेंगे सेफ में?
देखिए, ये उसी तरह जिस तरह हमने किया. फॉर एग्जांपल, आप बॉटम फर्स्ट लेयर में नंबर 8 बार यूज कर रहे हैं, ठीक है. लेट्स सपोज नंबर 6 बार यूज करें, तो नंबर 6 की एरिया आपके पास 0.44 है, और इसको आप 6 इंच पे प्रोवाइड करें, which is equal to 0.5. तो आप कितना एरिया प्रोवाइड कर रहे हैं? आपने 0.88 एरिया प्रोवाइड कर दिया इंच स्क्वायर पर फुट. दूसरे लेयर में आप नंबर 8 बार यूज करें, तो नंबर 8 इज 0.8 डिवाइडेड बाय नंबर 6 इंच पे करें, तो दैट इज इक्वल टू दिस. तो ये दोनों आप सम कर दें. So the total area you have provided is 2.48 inch square per foot. Now, if you want to check in ETAB, and you want to check it with the any diameter you can select. If you select number 6, so number 6.44 divided by this total area you want to provide, and then multiply with 12, you will get 2.12 inch square, 2.12 inch center to center. So you have to select number 6 bar, and spacing is 2.12. It will represent 2.48 inch square per foot reinforcement. बिलाल
Okay,
लता
sir,
क्वेश्चन
thank
को
Yes, sir, ما करो.
उस क्लियर शो दा
Yes, sir,
that's
clear.
different
Sir,
जी जी
दे कि मुंगा असल की दो बार यूज करे यो नंबर 6 यो नंबर 8 नु दा सेकंड स्पेसिंग बया मुंग पदे कम डाया बार बांदी फाइंड को पदे ज्यादा वाला नंबर 6 बांदी का नंबर 8
दा सेफ की चेक कोली आदे
यस सर दा
सेफ
वाज
की तो
2.12
सेफ की तब नंबर 2 बार हम चेक कोलेशी
यस सर
पर 3 चेक कोलेशी पर हर चेक कोलेशी doesn't matter as long as you know the total reinforcement तो सुनो प्रोवाइड के आगे मुताबिक बता
यस
कम बार थी उसके चेक किया आगे मुताबिक स्पेसिंग रो बस
यस सर थैंक
सर इतनी कंजेस्टेड रेनफोर्समेंट में कंक्रीट की कास्टिंग भी एक मसला होता है
कहाँ पे
ये कोई
कंजेस्टेड है
सर मतलब आपने 2 इंच बताया स्पेसिंग ना 2 इंच स्पेसिंग बहुत कम है सर
2 इंच स्पेसिंग को नमूना वर्क होगा ना बच्चा 2 इंच स्पेसिंग हो सिर्फ चेक को मच 2.48 इंच स्क्वायर पर फुट रेनफोर्समेंट वर्क में وظيفة السيف كي تشيكوما نوزوكا نمبر 6 بار يوز كما نوزيا بدي سبيسنج تشيكوم
ठीक
مو خو برووايد كودل دا نمبر 6 بس 6 انچز باندې کنه خو په سیف کې زه چیکوم چې یاره دا بکارو کې کو نه کی نو زه کدلته نمبر 6 بار یوز کوم نو زه سمره سپیسینګ استعمالو هغه سپیسینګ تاسو سره 2.12 راغلی چې ته نمبر 6 بار سلیکټ 2.12 spacing ورکی it will represent the reinforcement total reinforcement of 2.48 inch square per foot ठीक है जी
ओके
the difference should be made I will recommend you for all of the young or senior engineers if you are doing design please do not decrease the spacing of the bars in raft less than 6 inches because there is another requirement of serviceability that if the spacing between the two bars clear spacing is greater than 6 inches so that the raft there will be cracks shrinkage cracks in the raft.
Okay sir.
So let us go to the overall review of the drawings that how you will present your drawings because I'm not going into the detail because drafting is not an easy job because you will design your structure or your building in 2 days but it will take 2 weeks for in drafting because many changes will be you will be doing many changes in the drafting or with the direction of the architect so it takes a lot of time in the drafting and after drafting the main issue and the hard job is to check the PDF and the final drawings so you do not send any wrong information to the client. So first of all you have to insert in layout the architectural drawings all of these whether it is basement to 1 basement 2 basement and then after that you have to go for the raft. So this is the raft bottom layer 1 bars and I have written it as a number 8 at the rate 16 so these are the bar represented which is the continuous bars so this will be the first layer and the second layer will present the second layer reinforcement for example if it is at the you have to present it like it this example this is the case so you have to go for the 12 inches because it will be visible like this you have to draw the reinforcement on the other side so this is how you will represent the second layer I copy it in here You will put that reinforcement on all those columns where the second layer was required. So this is just for the reference to how you provide it, right? So this will represent the second layer of the reinforcement, and you will write, for example, this is first layer and this is second layer, and he will confirm these layer spacing from the section you will cut from the raft. So this is the second layer and this is the first layer. Same is for the top. This is the raft top layer at their 6 inch center. These are the continuous bar, and you can, let me copy this, and you can represent the negative bars as well as a second layer. So you will provide it as per the requirement. Right. So normally the negative bars are in here between the columns. So you have to show these bars like this, and as per the requirement. So let me copy it. I'm just showing you the procedure. You have to do it for the actual drawings of your project. Same for the other direction. You have to show this reinforcement. Let me copy this and rotate it. Place it in here and take the offset multiple, like this, and you can copy it in here as well. So you have to represent these bars on those regions where the negative top bars is required in layer 2. So you will write the raft top layer, and you have to provide the top layer in 3, which we have required in this region, because we are not doing in detail because it takes a lot of time. So this is how you will represent the raft, and you have to take a section on the raft so he can confirm the spacing and layers, and you have to take this section. For example, this is a section in which we will show the bottom reinforcement, 2 layers, 3 layers, and their spacing and the length of this second layer bars, right? So this is how you will represent the raft drawings, right? And you will learn, because I cannot do the whole drafting because the format is different for different consultancies. When you start working consultancy, the format will be different and all of these, and you will learn. There will be a ready-made templates in your consultancy, and you can use that by giving this detail. And you will not be doing this. This is not your job. This is the job of a draftman, right? Your job is to design it. So the next plane will be the column plane. You can see that column plane from basement to the ground floor, because it has this retaining wall, right? And you have to name this columns. If you have different sizes of column, you will name it C1, C2, and C3, right? And the next plane will be column plane from ground floor to top floor, because it does not contain any retaining wall, and the namings are the same, right? So this is how you will represent the column detail. So this is the column plane, and after the column plane, you represent the columns, right? So this is the column which we have designed. It is 36 cross 36, and that we have the 32 number 6 bars, and this is the spacing we have calculated previously. And remember that this is C1 and this is C2. I have forgot to change that. This is actually C2, right? The outer columns, these are called as C2. Let me change it by using the find command, and I will change this name. This is C2, the outer, and this internal is C1, right? This is just for the, let me cross it, because I remember that during the design, the reinforcement were very high for the 30x30. So I have changed that column to 30x36 or 36 now. So there is only one column in C1. That's why I have written it as a C1. So this is how you will represent the column plan. First of all, the column plan and this column detail. You can also provide the longitudinal reinforcement detail for the column. I don't have any time to draw that. So we'll represent the number of bars, 32, number 6 bars, and this strips, that is number 4 at the 7 center, right? The next one is the beam plan, that we have to show the beam plan, and that will be the beam plan from ground floor, right? So ground floor beam will be different because it has the ramp. There is a ramp, okay, because you cannot show this beam. So you have to name different beams. If you have one kind of beam, which in our case is B1, so you have to name all of these as B1. And then the next plane will be from a beam plane from the first floor to top floor in our case. And again, we have different same beam, because in this side we do not have any beam, because the thickness of the retaining wall is 12 and the thickness of the width of the beam is same. So when the width of the beam and thickness of the retaining wall is same, you do not have to provide any beam because it will act as a beam, right? So but in the top we have this B1, we have written on the edges, right? So this is how you will present the beam plan, and after beam plan you will present the beam section. In here we have this B1, in which you will show this longitudinal section, in which we have this 8 feet containment of the bars, right? That is L by 4 and L by 3. You all of know these things. And this is the spacing we have calculated from the ETAB. And this is the length of the interior support. It is coming from L by 3 and L by 3 plus dimension of the column. And this is the section you will show that we have calculated, that at the bottom we have 4 number 6 and we have 4 number 6 top, and then the 2 number 6 will be continuous, and these 2 will be contained to make it economical. And these are the stirrup spacing, number 4 at Z, 4 in center. This was the second beam, B2, in which we require 2 number 8 bars at the mid for the torsion. These are the torsion reinforcement. All of other details are the same, and you can see these 2 bars are shown as a longitudinal section. There's a 2 number 8 bars. So this beam detail is different from B1 because we have extra 2 number 8 bars at the mid depth of the beam. This is designed for the torsion, and there is no torsion, so there is no need of the torsion reinforcement. Right, the next will be the detail for the slab, and this is the ground slab plan. All bottom bars are at number 4, 10 centimeters. We have calculated previously, and this is, you will show the ramp. There is no bars in here, and you will show these bars as a continuous bars, right? And these are the slab bar reinforcement plan from the first floor to top floor, and all bottom bars are number 410 centimeters, right? For the negative bars, you have to show it differently, because I do not have much time, because it takes a lot of time, especially the negative bars. So you have to show it in plane as well and in section, just like we did in this ramp. For example, this is the beam, so you have to take L by 3 from this panel, L by 3 from this panel, and add the width of the beam, and after that you have to draw this negative bar, and you have to show it with 2 or 3 bars, and you have to write again in here that all the top bars are number 4 at the rate 18 centimeters, right? So I have done only this thing, and you have to show the dimension as well, right? So you can draw it for the all. You have to draw these bars and give the dimension for all of the panels. and write this spacing that the top bars I add this much. Same is for the other plane and so on if you have other planes as well. And then you have to take a section on the slab, and this is the section, right? So you have to show the negative bars number 4 at the rate 18 center. This is the main bar, and these are the supporting bars, which you can give a number 3 at the 24 center. These are the bottom bars. This is slab thickness, and the bottom bars are number 4 at the rate 12 center, and same is for the interior. You can also show this dimension, but there is no need to show in here because you will show it in the plan, and you can take this section and you have to show this section. The next one is the detail of the retaining wall. You have to show the retaining wall like this. For example, this is a foundation, and you have to show the thickness of the retaining wall and then the reinforcement. In our case, it was number 4 at the 12 center. These are the flexure reinforcement, these longer one, and these are the shear reinforcement for the retaining wall, right? The next one is the lift wall detail, in which you have to show these flexure. These are the flexure reinforcements, and these are the shear reinforcement. In our case, both are same number 4 at the 12 center. These are the additional things. You can see these stirrups. You have to provide these stirrups. This is a code requirement that for the controlling of the cracks, you have to provide this. You can, there is some check on this detailing, right? So you can provide it as a 30 inches or 24 inches. You can do it, and you can check it for the detailing manual of the ACI, right? So you have to provide these stirrups to control these cracks at the edges. The next one will be the detailing of the shear walls, that you have to show the shear wall like this. You have to click the thickness, how much thickness. For example, if it's 12 inches, it is 15 inches. You have to write the thickness and then its reinforcement. In our case, it was number 4, 12 inch center for both flexure and shear. And you have to show the columns. If it is attached to the column, so you have to show it like this. So this is how you will present your drawing to the client, and you will done with your project, right? So this was the whole story about the drafting. If you have any questions, you can ask.
Sir, I understand it all, but I would like to add some information about stair. We don't design stair, but can you add some comment or some extra information about the stair?
On the stairs,
Yes.
do you know the minimum reinforcement for the slab? You can provide minimum reinforcement in the stairs. There is no need to design the stairs.
Minimum reinforcement of
minimum
same
reinforcement
slab.
Same for the slab.
If your slab is
as long as you have very long stairs, for example, the width of this stairs are 20 feet or 30 feet, so then you have to properly design that stairs. But the normal residential and commercial building stairs are, the reinforcement are given as a minimum reinforcement for the one-way or two-way slab.
Okay, sir, I understand.
Let me stop this and review this link so we can discuss, right?
Okay, sir.